Welcome everyone. In last class we have seen some concepts related to cloud computing, especially deployment models and service models. Deployment models explain what is the nature of implementing the cloud, means according to the type of user. If it is open, then it is a public cloud. If it is for an organization, means restricted to organization, then it is private. And if it is for a particular community like NGOs, like businessmen, such clouds are categorized as community cloud. And if it is a combination of public, private, and community, then it is hybrid cloud. In service models, we have seen what is infrastructure as a service, means how cloud computing works as an infrastructure, and what is platform as a service, and after that software as a service, and finally network as a service. Here is a very good video which shows how IoT can solve or optimize our daily life from normal life to professional life. So let's see the video.
The Internet of Things has emerged as a critical driver of our technological future, both at work and at home. With 6.7 billion data-generating devices in use today and 20 billion projected by 2020, the influence of IoT is everywhere, touching nearly every part of our lives. Take Leon. He's a senior manager of manufacturing operations at a large paper factory, responsible for keeping the production line operating at peak performance, meeting strict service level agreements for uptime and output. Rising before dawn after a restless night's sleep, he prepares for the day utilizing his IoT-enabled smart home, asking his Alexa voice assistant for a weather report, a rundown of the day's calendar, and recommendations for the fastest route to work. Meanwhile, noting his lack of Z's, Leon's sleep tracker has already told his espresso maker to add an extra shot. Smart sensors turn lights off as he leaves the house, saving money on electricity. Arriving at work, Leon views an equipment health report sourced from thousands of connected devices, machines, and sensors running on Amazon free RTOS, each measuring critical KPIs on the factory floor. Everything from the speed and vibration of the conveyor belts, the strength of the paper being produced, and even air quality. The report also provides suggestions for maintenance. Using AWS IoT Analytics, device data is filtered, transformed, and stored using machine learning models built and trained in the cloud. Leaving work, Leon is surrounded by IoT solutions. Farm fields enabled by AWS Greengrass measuring moisture levels in the soil, and using cloud-trained machine learning models, adjust watering patterns even when internet connectivity is spotty. A hospital where connected devices acquire and process critical data, improving diagnostics and patient care in real time. Overhead, an airplane connects to the cloud, using analytical models to personalize in-flight entertainment choices. Returning home, IoT technologies have already lowered Leon's air conditioning in response to an unseasonably cool evening. IoT enables Leon's smart TV and entertainment system to automatically turn on when he walks in the door with his favorite show queued. Ready to relax, he has Alexa prep one last cup of coffee. Decaf this time.
So we have seen in this video that how IoT can be used to optimize our connected life, means from home to street to industry, everything. Means and you think an application in any field of your life, you can implement IoT to optimize that particular phase of your life or the stage of your life, or the portion of your life. So we will see some features of AWS which is more or less similar in all the cloud services, whether it is Google Cloud IoT, whether it is ThingsBoard IoT, or Azure IoT, IBM IoT, anything. The main purpose of these cloud services is to ease your implementation, means ease of doing or ease of implementing the IoT. So we will first see what is device software. Device software here is used to connect your device and operate them at the edge. Edge means at the device level. Two types of device services or device level services are provided by AWS, and it is free RTOS. It is an OS for microcontrollers that make small, low power edge device easy to program, deploy, secure, connect and manage. It means this works as an operating system inside the device in order to deploy it, means execute it, secure it, and more often connect and manage it. After that, AWS IoT Greengrass. It is a software that lets you run a local compute. It means if you want to do some computation over on the board, means on the IoT device, it will help you to do that. Beyond that, messaging, data caching, synchronization on connected devices in a secure way. Security is the main. We have AWS IoT Core. It lets connected devices easily and securely interact with cloud applications and other devices. Means AWS IoT Core has a working of connecting the device to the cloud applications. IoT Device Defender, it continuously monitors and audits your IoT configurations to make sure that they aren't deviating from security best practice. It means it will continuously monitor all the IoT devices whether they are secure or if any unintended event happens, then it will report, it will create an audit log in which it will show that particular device has some issue in terms of security. AWS IoT device management makes it easy to securely register, organize, monitor, and remotely manage IoT devices at scale. It means it has full responsibility of managing all the devices. In what form? If suppose in future you are increasing number of devices, then even devices, this particular service is responsible for that, means device management. After device management, we have some analytics service like AWS Analytics. It makes it easy to run sophisticated analytics on massive volumes of IoT data. It is sure that there is not a single IoT device. We have at least 100 or more than even that. In video we have seen there are billions of IoT devices. So AWS manage all those devices, and all those devices are generating data, and those data can be AWS cloud can easily detect and respond to events because we have to take some actions after getting those data, and after some analysis we have to take some actions in the form of actuators, actions in the form of display, actions in the form of SMS or email, like that. AWS IoT Things Graph, it makes it easy to connect different devices and cloud services to build out IoT applications. It means you can connect device, means it helps in connecting devices, means you can say that it gives a visualization of how all devices are connecting to the cloud and how data is coming and how data is going, like that. Similarly, Google Cloud IoT and Microsoft Azure IoT also provide near about same services. similar services, and all these services are paid. AWS is, everyone say that we are free, but you have to give your credit card information. So if you have credit card, then you can implement your IoT services with some restrictions for at least 1 year in AWS. After that, they will charge you, you some amount according to your usage. So we will see one example of IBM Cloud IoT. Here, IBM provides services like device management. It is there in AWS also. Responsive scalable connectivity. It is there in AWS also. Secure communication. It is there in AWS also. Data lifecycle management. It is there in AWS also. So IBM is also having same features, but with maybe with some different pricing or different ease of using. Here you can see in the figure that here we can see in the figure that we have our device means, and it is sending data to the cloud means IBM Watson IoT platform. It is sending and receiving data from the cloud in the form of MQTT, and we have studied how MQTT is used to transfer data from the sensor to the cloud or to the server using MQTT broker. MQTT is a very good method in case of IoT because we have to send us data in form of a single string or a set of words, and this IoT platform can be accessed using APIs, and these APIs are called as REST APIs, and these APIs give data from the cloud to create an application analytics. Means these data, the data over the cloud in IBM Watson IoT platform can be accessed via API, and and those data can be used for analytics. And IBM Cloud IoT even provide analytics tools, pre-existing analytics tools. We will see one more example like Blink Cloud IoT. It is somehow different than other cloud services because it provides drag and drop options. Like we will see or we will implement this Blink Cloud IoT in our practicals. At that moment, I will show how Blink Cloud is very easy to, to think for an application of IoT. And it is very easy to create your app using Blink. If you have one device like Arduino with Wi-Fi, or Arduino with Wi-Fi Shield, or Arduino with Ethernet Shield, ESP32, ESP8266, Raspberry Pi, anything which has some internet connectivity or external connectivity option in form of Wi-Fi or Ethernet. After connecting your device to Blink app or the Blink website, you can see your IoT data over the Blink app. So, in order to create a Blink application, first you have to download your Blink app from iOS or Android, and after downloading Blink app, you have to install the Blink library in the IDE, and IDE can be Arduino or Python, C++, any IDE which supports IoT programming. After that, connect your hardware to the Blink. And for that very purpose, you will need a device authentication code token, and it will get created in your Blink app. There is an option of creating authentication token, and that authentication token is used to connect your device with the Blink app, and that very authentication token will also allow you to export or import the data from the cloud or send to the cloud. And after that, you can, after getting those data, you can do so many things like analytics, displaying, anything, whatever you want to. For today, and in next class, we will see some more things related to IoT. Thank you.